Welcome to my explanation of absolute value. What is absolute value? Well, I know that a lot of you think it's that thingy, those two lines, that when you put something inside of them, everything becomes miraculously positive. Well, technically that's true, except we're going to really define absolute value of x basically as a distance. It's the distance from zero on a number line. So when I say to you that the absolute value of x equals 3, it basically means that if I were on a number line and I were going to look at 0, x to have an absolute value of 3 would have to have a distance of 3 from 0, which means it could either be 3 units to the right at positive 3, or it could be 3 units to the left at negative 3. Both positive and negative 3 have a distance of 3 from 0. With that said, we can up the ante a little bit and look at an equation such as the absolute value of x minus 3 equals 2. Now we're basically saying that the distance from x and 3 is 2. So if I think of my number line, I'm saying I want to find what's 2 units away from 3. Again, we can go now 2 to the right, which would put us at 5. Or I could go 2 to the left, which would put us at 1. So if I solve this equation in a kind of number line idea, we would see that our answer would be both 1 and 5. Now, this was actually a pretty simple one to solve with a number line, and they will get more difficult as we go along, of course. What do you expect? So let's take a look at this same problem, the absolute value of x minus 3 equals 2, from just, quote, an algebraic perspective. With this, I mean to say that what if we didn't want to draw a number line? Well, let's think about this. We know that what's inside the absolute value symbols, when we take its absolute value, has to have been either negative 2 or 2, because of both of them are 2 units from 0 on the number line. So if the inside term is positive, okay, well, actually, let's think of it this way. If the inside term can already equal 2, that way, when we take its absolute value, it stays 2. Or the inside term isn't 2, it's negative 2. That way, when you take its absolute value, you'll get positive 2. So in a sense, we're basically saying here, just to kind of put this like a little aside, that if you took the absolute value of 2, it would be 2. Sorry, I fell a little bit off the board there. And if you took the absolute value of negative 2, it would be 2. So that means that what's inside of the absolute value symbol has to equal 2, or it has to equal negative 2. So when we solve this, we're going to get x equals 5. And if we add 3 to each side, we're going to get x equals 1. The same two answers we got before. Okay, let's again up the ante a little bit. Let's go right now and say, what if we had 5, absolute value x plus 3, minus 3 equals 7? What's your gut instinct here in terms of solving? I'm hoping you're thinking, let's isolate the absolute value. So we're going to add 3 to each side, which will give us 10, and divide by 5, which will give us 2. So now we're going to have the absolute value of x plus 3 equals 2. Now, again, let's think about that. The only two things that have an absolute value of 2 are 2 and negative 2, which means that what's inside the absolute value symbol is either already 2 or it's negative 2. In either case, when we solve, now we're going to get x equals negative 1 and x equals negative 5. What I'm hoping you see is this idea that when we solve an absolute value equation, the first thing we're going to do is isolate the absolute value. And then we're going to set up two equations. And the two equations are really going to be resulting from saying either what's inside the absolute value is equal to the right side, or it's the negative of the right side. And we'll go with that a little bit further in a moment. And I'm going to bring up a third point now, and that you're going to see in the next example is that we're going to check for extraneous roots. So here goes. Let's take the following problem. The absolute value of 3x plus 2 equals 4x plus 5. What I want you to notice is that now we have a variable on the right and the left side. This can bring in the situation of extraneous roots. Now, we know what's inside this absolute value symbol is either already equal to this, which will result in the equation 3x plus 2 equals 4x plus 5, or what's inside the equation is the negative of that other side. And I'm trying not to run off the board here, because if it's the negative of it, then when we take its absolute value, it'll become positive. So we have two resulting equations, one equal to the positive of the right side and one equal to the negative. Again, we're going to solve this. If I subtract 3x from each side here, I'm going to get x. If I subtract 5 from each side here, I'm going to get 2 minus 5 is negative 3. If I go here, I'm going to have to do a little bit more work. I'm going to get 3x plus 2 equals negative 4x minus 5. If I add 4x to each side, I'm going to get 7x. Subtract 2 from each side, I'm going to get negative 7. And I'm going to get x equals negative 1. Now, what can happen is both of them check, one of them checks, or none of them checks. Okay, so let's just kind of do a mental check right now on the negative 3. If I plug negative 3 in on the right, I'm going to get 3 times negative 3 is negative 9, plus 2 is negative 7. The absolute value of negative 7 is 7. If we go to the right side, 4 times negative 3 is negative 12, plus 5 is negative 7. Doesn't check. This is an extraneous root. Now, if I go to the other side, sorry about that, 3 times negative 1 is negative 3, plus 2 is negative 1. The absolute value of negative 1 is 1. 4 times negative 1 is negative 4, plus 5 is 1. Okay, one more example before you try some on your own. Here goes. Let's take, I'm just thinking. Let's do absolute value of 3x minus 2 equals negative x plus 6. Remember, absolute value is going to result in two equations. Either what's inside the absolute value already equals the right side, or what's inside the absolute value is the negative of what was on the other side. We're going to solve here, and we're going to get on this side 4x equals 8, so x equals 2. And on this side we're going to get 3x minus 2 equals x minus 6. So 2x equals negative 4, x equals negative 2. Tell me, do they both check or not check? Okay, quick check on the right side. 3 times 2 is 6, minus 2 is the absolute value of 4, equals negative 2 plus 6. 4 equals 4. Beautiful. And on the other side, ran out of a little room here, so we'll just do it in our heads. 3 times negative 2 is negative 6. Minus 2 is negative 8. The absolute value of negative 8 is 8. On the right side, we have negative 2, which is 2 plus 6 is 8. So on this one, you'll have 8 equals 8, and it will also check. Here's a couple for you to try. Hope this helped.